In this lesson, we will learn how to compute binomial probabilities using a formula. In a previous lesson, we covered what binomial experiments are. And if you missed it, it is an experiment that has two outcomes, either success or failure, hence the prefix of the name. So in a binomial experiment with n trials, if the probability of success in each trial is denoted as p, then the probability of exactly k successes is given by this formula. And notice that this factor, the one shown here, represents the binomial coefficient. You might recognize this as the combinations formula. So how many ways can we sort k items from a total of n items? The rest of the factors are self-explanatory. P to the power of k and 1 minus p raised to the power of n minus k. We can denote all of this using the simpler notation represented here. So with that being said, a pharmaceutical company claims that a new drug is effective 75% of the time. So the probability of success is 75%. I'll represent that as the letter P, 0.75. Assuming the company's claim is accurate, if we test the drug on 20 patients, what is the probability that exactly 15 people will benefit from the drug? So from here, I can say that n is 20 and k is 15. We will write down b bracket 20 comma 15 semicolon 0.75. So now we'll substitute these into the formula shown right there. We have c bracket 20 comma 15, that's the binomial coefficient, times 0.75 raised to the power of 15, multiply 2 1 minus 0.75 raised to the power of 20 minus 15. This can be placed into your calculator. If you don't know the combinations formula, it's shown on your screen, but you can easily calculate this by typing 20, and our function for combinations is right there. So shift this button, 20, choose 15. Multiply 2, 0.75 raised to the power of 15. Multiply that to 0.25. We're subtracting 1 minus 0.75 raised to the power of 5. As you can see, the probability of exactly 15 successes is 20.2%. 0.202 or 20.2%. So to conclude, if we test the drug on 20 patients, the probability that exactly 15 people will benefit from the drug is only 20.2%. Let's try another example. Maria has fallen behind in her anthropology class, and her instructor just announced a pop quiz consisting of 10 true-false questions. If she must get 6 or more correct to pass the quiz, what is the probability of passing by simply guessing? In order for Maria to pass this quiz, she needs to get 6 or more correct. So there's a scenario where she gets 6 out of 10. There's a scenario where she gets 7 out of 10, leading all the way to 10 out of 10. What we have to do is calculate the binomial probability for each of these and add them up, which means we have to use this formula 5 times. For this one, we can represent it as 10, 6, comma 0.5, because remember, there's a 50% chance that you will get it right if you guess each question, plus, again, for this scenario, 10, 7, again 0.5, and the rest should look like this. Remember that we add probabilities when each probability pertains to mutually exclusive possible outcomes. So because she can pass with 6 out of 10 or 7 out of 10 or 8 out of 10 and so on, this means that they're mutually exclusive, and so you can add them. The probability of this is 10 choose 6 times, recall that the formula was p raised to the power of k, so 0.5 raised to the power of 6 times 0.5 raised to the power of 10 minus 6, which is 4. You see I wrote down 1 minus 0.5, that's how I got this. And 10 minus 6 is 4. We get that value, 0.205, 0.205, and you would calculate all of these the same way. So I'll just add another digit here. If you calculate this correctly, you should get a value of 0.1172. This one is 0.0439. This one is 0.0098, and the last one is 0.0010. Adding these up, we get a total of 0.377. So 37.7% that she will pass the quiz simply by randomly guessing all of the questions. So that's around 40% that she will actually pass.